Hello and welcome, everybody. We're glad you're here. Thanks for joining our webinar AI meets XL3 Vibe Coding Custom Dashboards in Minutes. My name is David, and I'm a dual student at NTI Audio, and I'm currently finishing my electronics degree. And I'm happy that I'll be the one walking you through this session today. With me is Thomas, our CTO, who will be available for your questions during the presentation. So, what are we actually doing today? We're looking at something very practical: how AI can help developers build custom XL3 applications significantly faster than starting from a blank page. Just to frame it correctly from the start, we're not talking about AI as a magic wand or as a replacement for engineers. We're talking about using it as a real development tool, one that produces reliable results when used right. By the end of this session, you'll have seen a real working XL3 web dashboard generated with AI. And more importantly, you'll understand the workflow behind it. Here's what we'll cover today. We start with a quick look at what we actually mean by vibe coding, because the term gets thrown around loosely and we need a more useful definition. Then we'll talk about the general approach, what AI already knows, what it doesn't, and what we need to provide ourselves. After a short overview of the XL3 APIs, we move straight into the practical part, a live demo where we use AI to generate an XL3 web dashboard in real time. So method first, then live application of that method. But before we dive in, let me be clear about the goal. This is not a beginner coding session. We're assuming you're already comfortable with software development. The real question we're trying to answer is, how do you use AI productively for a device-specific API without losing correctness and without burning time on trial and error? The answer isn't just generate some code and hope for the best. It's about having a repeatable workflow, preparing the right input, guiding the AI effectively, and getting to a first working application much faster than from scratch. If you take one thing away today, let it be this: AI becomes drastically more useful the moment you stop treating it as a black box and start treating it as a tool that needs a proper interface definition. So, what do we mean by vibe coding? The popular definition is: describe what you want in plain language, let the AI rate the code, and hope for the best. And for generic tasks, that actually works pretty well. But the moment you introduce real interfaces, real protocols, or better said, device behavior, that approach breaks down very fast. So for this webinar, we define it more precisely. Vibe coding means using AI to generate software from a clearly prepared technical context. The core idea is simple. AI can only reason reliably about things it already knows or things we explicitly tell it. But what does it already know? Plain text, markdown, web standards, and structured data. These are areas where AI is generally strong and where it can generate reliable code with minimal guidance. On the other hand, API documentation, protocol details, data formats, or application requirements, these are the things we have to bring to the table ourselves. Because the AI cannot have any knowledge of that, because it's proprietary device behavior. So we have to describe that properly. So instead of saying, build me an XL3 dashboard, we give the AI a precise description of the interface and let it generate from that. That's the difference between hoping and engineering. That brings us to the core tension. The problem is, generic AI coding is fast, but it's unreliable when the task depends on a product-specific interface. Without enough structure, the AI fills gaps with assumptions, and in device-oriented software, assumptions are exactly where bugs come from. The opportunity is, if we describe the interface clearly enough, AI becomes a very effective accelerator. Boilerplate, UI, or parsing logic, all generated quickly with a solid foundation. So the key is not to ask the AI for less. The key is to give it a better input. And that's really the central idea of this whole session. Optimize for correctness and repeatability, not just for generation speed. At this point, a natural question comes up. Why not just paste the official manual into the AI? The short answer is because manuals are written for humans, not for machines. A good manual is rich with context, explanations, optional features, and background information. Exactly what a human reader needs to understand a product. But for AI assistant implementation, that richness of information actually works against you. Critical rules get buried across many pages. Details mix with broader explanations. The AI may combine things that shouldn't be combined or miss that one specific rule that actually would matter. The manual isn't the problem, the format is the problem. It's not built for this use case. What works much better is a smaller, focused document that tells the AI exactly what does matter for the application we want to build. And this is where Markdown files come in. And they are really the heart of this workflow. Instead of handing the AI a large manual, we give it a compact Markdown file, an AI cheat sheet that contains the essentials only, describing the relevant interface behavior in a form that's easy to consume and act on. The goal isn't to replace the official documentation. The goal is to extract the parts that matter for code generation and turn them into a working specification. But why Markdown specifically? If we look at the benefits, first of all, it's machine readable, meaning the structure is already optimized for how AI processes inputs. Moreover, it's precise, which directly reduces hallucinations. That means the AI is less likely to invent behavior when the behavior is clearly spelled out. And it's efficient, it's saving tokens and processing time. And last but not least, it's simple. You can edit it from nearly anywhere. You don't have to install any special tools for it. And of course, there are some drawbacks worth being honest about. It requires some prep work. Someone has to manually extract the right information from the original documentation. And there's the garbage in, garbage out principle. If your markdown contains errors or typos, the AI will replicate them faithfully. And since markdown is text only, anything visual, like complex charts, diagrams, or signal flows, have to be described in words instead. So yes, writing the markdown file takes effort, but it's a one-time investment. And once it exists, you can reuse it across many different prompts, projects, or even for different AI tools. And instead of re-explaining the interface every time, you just can use this markdown file. And on the right-hand side of the slide, you have an example of a short cutout from the markdown file. Before we move to the workflow, let me quickly position the XL3 APIs so you know where today's focus fits. The XL3 offers three main options, and each one serves a different purpose. The basic streaming API is what we'll be using today. It pushes the live results of the 123 screen and the bar spectrum to up to 20 clients simultaneously. And that's in JSON format over WebSockets. It's read-only, requires no additional license, and is specifically designed for dashboard-style applications. It's simple, focused, and available out of the box without any additional cost. The Advanced Streaming API, which is a paid option, goes significantly further. It streams SPL data, audio, state of health information, weather data, and it even supports retrieving historical data. So this is the right choice for professional noise monitoring applications running unattended in the field. The Control API, also a paid option, is a different kind of interface entirely. Instead of streaming, it lets you remotely control the device and query measurements results on demand. You can start and stop measurements, configure the device, read back results or spectrum data, and even switch between measurement functions. It's aimed at industrial setups like test benches or end-of-line testing scenarios. But for today, basic streaming API is the natural choice. It's self-contained, well-defined, and gives us the most direct path from live device data to a visual web interface. And that's exactly the kind of focused scope that works well for this kind of vibe coding demo. So what does the actual workflow look like? It can be broken down into 4 steps. First, you have to define the relevant API behavior in a structured Markdown file. That's the preparation work we talked about. So turning the interface documentation into something the AI can actually use as a specification. From there on, you can feed it to the AI assistant. The approach works whether you're using Copilot, Claude, ChatGPT, or any other AI assistant. The quality of the output depends more on the quality of the context you give, not which tool you pick. The next step is to generate the code. Depending on what you want to build, that might be HTML and JavaScript for a browser-based dashboard, or Python for a backend client. But the workflow stays the same either way. On the last step, and this is listed as optional, which I think is worth a comment: bug fixing and styling. It's optional in the sense that sometimes the first result is already close enough to use, but more often you'll want to refine it. And that's fine, that's engineering. AI doesn't remove the iteration loop. It shifts the effort from writing boilerplate manually to specifying behavior clearly. That's different kind of work, not less. But here's where the approach really pays off over time though. Once your Markdown specification exists, generating variants becomes trivial. A minimal dashboard, a styled one, a different layout, or different charting libraries, those all become small follow-up prompts, because the hard part is already done. Now let's see this in practice. What I want to show you is not the polished final product, I want to show you the workflow in real time. I'm going to use the Markdown file as a context for the AI and ask it to generate a browser-based application that connects to the XL3 live stream and displays the incoming measurement data in a structured web UI. So let me switch over to Visual Studio Code now and let's start the vibe coding. For this demonstration, I'm using Visual Studio Code with GitHub Copilot. I'm using the Pro version, so if you're working with a free account and get less complete results on the first try, that's expected. Just refine the prompt and iterate. I'll be using Copilot Chat in agent mode for the code generation. So as you can see, we already have the basic streaming API Markdown file in the correct folder, and we can put it as a context in the chat window and start prompting. We could enter something like, we could enter something like create a HTML CSS dashboard that connects to the XL3 basic streaming API via WebSocket that displays all 1, 2, 3 measurements and the spectrum data. The entire UI structure shall be derived from the message settings message. And we'll tell the AI to follow the attached Markdown file specifically. The user shall be able to enter their connect key and their password. All right. While this generation runs, let's take a closer look at the Markdown file itself, because this is what the AI actually is working from now. Let me walk you through the parts that matter most. First of all, if you haven't seen a Markdown file yet, this is exactly what it's about. It's like a text file with some rich text formatting. It can simply be edited in VS Code or some other text-based editor like Notepad or something, and it has to be compiled to get a good view. So if we press the preview, we can see that the formatting has been applied, and we can have a look at the API definition as a Markdown file. One of the first things you will have to describe is where the WebSocket has to connect to. So the endpoints are defined here. The next step is the startup sequence, which Also has some specialties in the XL3 basic streaming API because first of all, it wants a password from you. Then you have to send the password. And if the password is correct, you get a settings message straight away. You don't get an acknowledgement or something, you just get the settings message. So this contains the setup that you're running on the XL3 123 screen. And after that, the data comes in every half a second in this case for the basic streaming API. Another important thing is the message model. So we give the AI the messages it can that it will receive. So we just give it some boilerplate that's empty. Later on, we also give it some filled structures, as you can see. So this is a settings message which is filled, and there's some real world data, so the AI can really reason from that and look at different cases. Another important thing in the basic API is that the settings message is the rule of truth, or the source of truth, sorry. Because as soon as you change the 123 screen on the XL3, the web UI shall also change with it, because it's otherwise the data names would just mismatch. And the fourth is robustness. So you give it also the data message, for example, or you could even go further and give the AI a whole sequence from the connection, in this case a successful connection, until the receiving of data. So as you can see, the AI is ready now. It created us an HTML file. So let's open it and have a look at it, what it's created. All right. So now it's asking us for a connect key and a password. Let me copy the connect key and enter the password. And let's see if it's working. Okay, that's looking good. Straight away, I can say that there are still some bugs in the UI, because if you have a look at the spectrum bars down here, they are numbered sequentially, and that's not correct, because these should be frequencies. But these are just the things that you can iterate through and bug fix with the AI really, really easily. We just have to tell the problems, and then from there on, it should be easy to fix. And if you haven't worked with the XL3 and the live streaming API yet, you will have the question where these values are coming from. So if we switch to the XL3 interface, this is just a connection to the XL3 in real time. You can see the values here and here. And the descriptions and the values of the data match the web dashboard exactly. I think we also have the timer somewhere. Yeah, up here, which is the same data. If we start the timer now, it should also follow. You can see applied settings, so it's got the new settings, and now the timer is running. And you can see it's the same on the XL3 and on the web dashboard. Yeah, and I think the other things are just preference now, because the main thing is working, and that's the thing that I was talking about before. It can be optional to do some more, let's call it wipe coding or just iterating through. But for this demonstration purpose, I think it did well enough. So I still have some things I want to tell you, so let's switch back to the presentation. Yes. So if you want to try this yourself after the session, the most valued takeaway isn't any single piece of generated code, it's the workflow. And to get started, you only need three things: an XL3 Acoustic Analyzer as your data source, Visual Studio Code, or any other IDE you're comfortable with. It really doesn't matter. And a GitHub Copilot subscription or a similar AI assistant like Claude or ChatGPT. Because the workflow itself is always the same. You start with a compact Markdown file and define the interface, Use it as a context and generate the first client. After that, you can validate it and look for critical behavior and bug fix and iterate from there. And to make the first step as easy as possible, we've published the Markdown file we use today in our GitHub repository. The link is on the slide, and you can also just scan the QR code to get there directly. It's ready to use as a starting point for you and for your own vibe coding sessions. What you'll build up over time isn't just code, it's a library of reusable interface specifications that can support any future developments with the same API easily. Let me close with 6 things I'd want you to take away from today. AI is fast, but fast only gets you somewhere useful if the technical context is clear. That's really the foundation of everything we've talked about. For device-specific work, a compact Markdown spec consistently outperforms wake prompting. The more precisely you define the interface, the more reliably the AI follows it. On the client side, that means the UI must always be driven by the latest settings message, in case of the XL3. So nothing hard-coded and nothing assumed here. And that's something that you have to define in the Markdown file. It also means handling real data defensively. So null values, unexpected formats, midstream structure changes, these are all normal conditions and not edge cases. And your client needs to be ready for them. So these are also things you have to specify in the Markdown file if you want to catch errors, or you can do it afterwards with the iteration. But the recommendation is, if you find such things, add it to the Markdown file. And the next time you won't have to iterate through it, and it should be working the first time. And finally, the lasting value here isn't that you can generate code quickly once, it's that you have a repeatable workflow, one that takes you from a documented interface to a working application reliably and, more importantly, repeatably and every time you need it. So to bring this all together, today wasn't really about AI generating code. It was about showing that the quality of what comes out is a direct reflection of the quality that goes in. The Markdown file, the defined contract and the explicit rules that listed in there, that's where the real engineering happens. The AI is just a tool that executes it. If you take one habit away from today, let it be this. Before you prompt, specify. The rest follows naturally. So thank you very much for joining us today. Thomas and I are happy to take your questions now and will stay online for a bit to answer them.